If you can turn to page 3 of your packet, we're going to talk about radian versus degree measure. Okay, so up until now, everything that we've really learned about was in degree measure, right? Something could be 90 degrees, 180 degrees. But what we're going to do today is we're going to learn about a different type of measure called radian measure. And this is just a different way that you can measure angles. Kind of like if you want to measure the length of something, you can measure it in inches, you can measure it in feet, you can measure it in centimeters, right? There's lots of different ways you can measure the length of something. Well, if you want to measure angles, you can measure it in degrees, or you can measure it in radians. Okay, so if we take a look here at the top of the page, right, it says converting from degrees to radians. All you have to do is multiply by pi over 180. So with these 3 examples down here, it says find the radian measure of each angle whose degree measure is given. Okay, so if we have 135 degrees and we want to convert it to radians, all we do is multiply by pi over 180. Okay, so in this first example right here, it gives us 135 degrees. So if we want to convert that to radian measure, what we're going to do is we're going to multiply. I'm just going to put a parenthesis here for multiplication. We're going to multiply that by pi over 180. All right, now, since this right here is a fraction, I'm just going to make the 135 into a fraction by putting it over 1. And let's just multiply straight across. So in the numerator, 135 times pi, I'm just going to write as 135 pi. I'm going to leave it in terms of pi. The only time you don't leave it in terms of pi is if the question asks you to round. I'll talk about that in a minute. And then in the denominators, 1 times 180 is 180. Okay, and then from here, again, I'm going to leave my answer in terms of pi, but I want to simplify 135 divided by 180. Both of these are divisible by 45, so 135 divided by 45 is 3, and 180 divided by 45 is 4, so this becomes 3 pi over 4. If you can't do that in your head, you can just, in your calculator, plug in 135 divided by 180 and hit math, enter, enter, and it'll give you 3/4. So we can rewrite this as 3 pi over 4. So let me actually just make that 4 look a little better. Okay, so 135 degrees is equivalent to 3 pi over 4 in radians. Now, if the question had said to round your answer, let's say to the nearest tenth, then what you would do is you would use the pi button in your calculator and you would plug in 3 times pi divided by 4, and you would just round that number to the nearest tenth. Okay, why don't you try out number 2 and 3 on your own, and then you can hit play when you're done and see how you did. Okay, so number 2, we're going to do the same thing. You would multiply by pi over 180, and I'll just put this 90 over 1, and when we multiply across, 90 times pi is 90 pi, and 1 times 180 is 180. So we have 90 pi over 180, and since 90 over 180 simplifies to 1/2, it leaves us with 1 pi over 2, which we just write as pi over 2. Okay, number 3, we're going to do the same thing. We're going to multiply by pi over 180. So when we multiply that, that gives us 300 pi over 180. And since 300 over 180 simplifies to 5/3, we could write that as 5 pi over 3. Okay, so now to convert from radians to degrees, we multiply by the reciprocal, by 180 over pi. Okay, so here they give us a radian measure. This is pi over 4, and they want us to convert it to degrees. Okay, so we're just going to multiply this by 180 over pi. Now, you can do this one of 2 ways. You can just multiply across the top, so you get 180 pi, and then multiply across the bottom, so you get 4 pi. And what you'll realize is that the pi on top cancels with the pi on bottom, and 180 divided by 4 is 45. The other way you could do it is if you prefer. You don't have to. But when you're in this initial step here, when we're multiplying by 180 over pi, you could just jump right into saying, all right, this pi on top cancels with the pi on bottom, and 180 divided by 4 is 45. Okay, so you can kind of skip this step if you want. Okay, try out numbers 5 and 6 and, hit pause, and then you can hit play and see how you did. Alrighty, so we're doing the same thing here. We're changing from radians to degrees. So when we do that, we multiply by 180 over pi. Okay, I'm going to do the kind of shortcut way. I'm going to cross off the pi's from the beginning. The one in the numerator cancels off with one in the denominator. And then I'm just going to multiply straight across. So 5 times 180 is 900. And then 6 times 1 is just 6. And 900 divided by 6 simplifies to 150. So I put my little degree symbol to show its degrees, and 5 pi over 6 radians is equal to 150 degrees. Okay, and then finally number 6, we're going to do the same thing. We're going to multiply by 180 over pi. So the pi in the numerator cancels with the pi in the denominator. And then if I multiply across the top, 11 times 180 is 1980. And in the denominator, we just have a 5. And when I divide 1980 by 5, I get 396 degrees. Now, I just want to point out 396 degrees, I mean, that is bigger than 360 degrees, right? So like if we had an angle and we wrapped around a full 360 degrees, to get to 396, we would have to continue on into the first quadrant until it became 396 degrees. Okay, this question is not asking that. I'm just kind of saying a little more than necessary here. Okay, if you turn to number 7 on the next page, it says, which diagram shows an angle rotation of 1 radian on the unit circle? All right, now, first thing I want to point out, radians does not always have to be in terms of pi. So you can see right here, right? There's no pi with this. This is just 1 radian. It's written as a number, which is fine. The other thing is, if we were to look at these diagrams, normally we like to think about like degrees when we look at a picture, right? Like you could see right here, this is showing a rotation of 180 degrees, right? This is showing a rotation of 90 degrees. So the first thing we're probably going to want to do is we're probably going to want to take this 1 radian and convert it to degrees. That way we can see which picture demonstrates 1 radian. All right, so here's our radian. We know to convert from radians to degrees, we multiply by 180 over pi. So, 1 times 180 over pi is just 180 over pi. Now, what we're going to want to do here is we're actually going to want to use the pi button in our calculator, and we're going to want to figure out what this is equal to as a number in terms of degrees. So if you plug in your calculator 180 divided by pi, it gives you, actually, you know what? I'm going to use the approximate symbol. It gives us approximately 57.3 degrees. So what we want to do is we want to look at these pictures and see, well, which one shows an angle of about 57.3 degrees. Well, that would have to be in the first quadrant, and it looks like this is the only diagram that shows an angle that looks to be about 57.3 degrees. So choice 1 would have to be our answer. All right, why don't you hit pause and try number 8 on your own, and then you can hit play and see how you do. Okay, so this one wanted to know in which quadrant would an angle rotation of 3 radians lie. All right, so if they give us radians, the first thing we want to do is convert it to degrees. So if we take 3 radians and multiply it by 180 over pi, that'll convert it to degrees for us. Okay, so let me just put this 3 over 1. So if we multiply our numerators, 3 times 180 is equal to 540. And then in the denominators, 1 times pi is just pi. So if we plug in our calculator 540 divided by pi, all right, that's going to give us approximately 172 degrees. All right, so then you just want to think about which quadrant that would lie in. So we know the first quadrant is between 0 and 90. The second quadrant is between 90 and 180. So since 172 falls in there, that would be in the second quadrant. Okay, the last thing we're going to talk about today is arc length and radian measure. So if you turn to page 5 of your packet, you'll see we have a formula here. It says S equals r times theta. And this formula relates the arc length to the radius of a circle to its central angle. Okay, so let me just label what's what in this formula. So S, okay, we could see is the length of the arc. So S would be the arc length. Okay. R would be the radius. And then theta is the central angle. Just going to put a little angle symbol. Okay, I'm going to do 2 examples with you from this section. So this is on pages 5 through 7, and then you're just going to do the rest on your own. Okay, we're going to start with a really straightforward one. So if you read the first one, number 9, it says, in a circle, so I'm just going to draw a circle, a central angle containing 1.5 radians. So let's draw a central angle. Okay, so here's the center of our circle, and the central angle would be right in here. Okay, so that contains 1.5 radians. So I'm just going to put 1.5 in there. Intercepts an arc whose measure is 18 centimeters. So it's saying this arc that it intercepts is 18 centimeters. Okay, they want us to find the length of the radius, so we're looking for r. Okay, so let's use our formula. S equals r theta. And if we plug in what we know the S, we know the arc length is 18. We don't know the r, the radius is what we're looking for. And we know the central angle, right? They tell us it is 1.5 radians. Now, one thing I want to mention, and this is really important. Your angle, your central angle, and here, put this up here. This is really important. When you go to plug it in, it must be in radians. Okay? If it's in degrees, you're going to have to convert it from radians to degrees. So this is in radians. That's really important. You're going to see some examples where they give it to you in degrees, and you'll have to convert it. Okay, so now back to number 9. If we want to solve for r right here, right, we know that r times 1.5 equals 18. So if we want to get the r by itself, just divide both sides by 1.5. Okay, so r, I'm just going to bring the r over here. R is equal to 18 divided by 1.5 is 12. So it's going to be 12. And the units for this arc length and the radius are the same. So if this is centimeters, this would have to also be centimeters. So it's going to be equal to 12 centimeters. And just to mention again, while we're talking about units, the units of your angle right here is going to be in radians, okay? And that's why they say radians right there. Okay, if you can skip ahead to number 14, it's on page 7. We're going to do that one together. And then after that, you're going to do the ones we skipped on pages 5 through 7. Okay, number 14 says, what is the length of the arc on the unit circle subtended by an angle of 120 degrees? Okay, so first thing let's do is let's draw a circle. And they want to know what is the length of the arc. So we're looking for this, right? We're looking for the length of the arc. So I'm just going to call that S. On the unit circle. Now, the unit circle, okay, what that means is it goes out 1 unit in each direction. Or another way of saying that is that the radius equals 1 unit. So radius equals 1. So let's put that here. Radius equals 1. Now it's subtended by an angle of 120 degrees. So it means that this arc is forming an angle right here of 120 degrees. Okay, so they want us to solve for S. So we know our formula is S equals R theta. Now the S is what we're looking for. We know the R is just 1. So substitute that with a 1. Now our theta, if you remember, we said that theta has to be in radians, okay? So this right here is in degrees. So not a big deal. If we want to convert from degrees to radians, remember we multiply by pi over 180. So I'm going to kind of do that within the problem, okay? I'm going to do times 120 degrees if we multiplied that by pi over 180, this is what it would look like, 120 pi over 180. Now, I mean, basically all you're really doing is, you're leaving it in terms of pi because it doesn't say it around, so you're just simplifying 120 over 180, which simplifies to 2/3. So you could write this as 2 pi over 3. Now, if the question did say, though, to find the arc length, let's say to the nearest tenth of a unit, then what you'd have to do is in your calculator you'd have to plug in 2 pi divided by 3 and write that as a number rounded to the nearest tenth. Okay, so you guys can try out the examples that we skipped on pages 5 through 7.